Hello to you all. Welcome to the session called What's New and What's Coming in Microsoft Cloud App Security. We're going to hyper-focus on remote work scenarios today. I'm Joanna Harding, and I'm located in Seattle, Washington, on the west coast of the U.S. I'm the Product Marketing Manager for Microsoft Cloud App Security. I'm pleased to be joined today by a teammate in Israel.
Hi, everyone. I'm Gal Zilberstein. I'm located in Tel Aviv, Israel, and I'm a Senior Product Manager in the Cloud App Security team. It's a pleasure to be here with you today.
Well, Gal, as you know, today we're all in this brave new world of remote work. For many organizations across the globe, remote work is awesome because it keeps us safe, but it's also really challenging to manage organizationally and also from an IT and security perspective. Cloud access security brokers, called CASBs, are an impactful way of making a difference in this landscape, and Microsoft Cloud App Security is here to help. By the end of today's session, our listeners should be able to understand our key capabilities in Cloud App Security and how it can help organizations address remote work scenarios. In our new world, users expect to be able to access corporate data and resources from practically anywhere. Also, users expect to be able to use the apps that they know and love in order to improve their daily quality of life. You can think of Slack or Zoom as an example. They don't necessarily want to be tied to the ones that they had to use when they were in the office. Meanwhile, organizations want to move to the cloud as quickly as possible. They want to reduce cost, increase security, and modernize infrastructure, especially the reduced cost part. But currently, traditional perimeter-based security controls don't enable this scenario in secure or in efficient ways. So it's quite the challenge for security and IT groups. This transition to remote work has totally pushed our digital transformation into a new era. Secure cloud adoption as part of digital transformation is the essential enabler for remote work. Microsoft Cloud App Security gives visibility over these assets, provides analytics into usage and control over the apps and resources that organizations need to use. As a quick reminder, in the Gartner category of CASB, we've been increasing our leadership and have gained the reputation of leadership in this category. Gartner has shared that by 2022, they estimate 60% of large enterprises will be using a CASB to govern some of their cloud services. They also shared that by the end of this year, a third of successful attacks experienced by enterprises will be through some kind of shadow IT resource. Since the CASB market is one of the hottest growing areas in the cloud security industry and expected to reach over $7.5 billion by the end of this year, we're fully invested in deepening our market value and sharing the best of features with our customers. Since secure cloud adoption means a lot of things to different organizations, there are some key scenarios that every organization needs to pay attention to in order to kickstart their cloud adoption safely. Briefly, our approach to CASB is based around 5 investment pillars. First, the discovery of shadow IT, which is the visibility to all applications in organizations. Second, threat protection, which is the protection against emerging threats and cloud-native attacks. How to identify, investigate, and automatically remediate those cloud threats. Third, information protection is about how you can make sure that your data is safe and prevent data leakage. Fourth, the access and identity protection pillar extends our capabilities beyond the traditional security perimeters, including zero trust principles, so that you can handle challenging scenarios like unmanaged devices and remote work. And last but not least, cloud security posture management, which is how we help the digital transformation from an advisory standpoint. This transformation is not happening only for users, it's also happening to the organizations. We help organizations to transform their implementations of the cloud and improve their cloud security posture through broad visibility, detailed analytics, and recommendations to ensure increased security and compliance across those organizations' original policy agreements. We as a security provider, of course, we care about consistent experiences for our customers, and we integrate heavily with our native solutions. We are continuing to deliver unified solutions and experiences with our Microsoft Threat Protection, Microsoft Information Protection teams and products. There's more coming in the Endpoint CASB solution, updates to our secure access alignment with our identity teams, and we continue to deliver more in the Zero Trust framework. UEBA algorithms and cloud security posture management are also part of our plans. We are here to help govern and ensure compliance and protection for any resource in your environment, whether you are leveraging Microsoft security and productivity products or not. So remote work has a few complex and interesting problems, and we want to focus on those today. A day in the life of a remote worker means interaction with many data resources and devices that are not currently in the purview of their IT management. Microsoft Cloud App Security helps rationalize the access as the user enters a session and adaptively manages that access throughout, watching the risk levels of the applications themselves and governing the data classification as the users move through their environment. Gail, would you kindly talk us through these scenarios and do some brief demonstrations?
Sure, Joanna. Today, I'm going to show you interesting scenarios that are super relevant to remote work and secure collaboration. We will talk about deploying app discovery using Endpoint CASB, our detections in UEBA, how we can prevent data leakage from unmanaged devices in real time, and lastly, what we can do to mitigate the risk of malware and ransomware. Should we start?
Take it away.
Sure thing, Joanna. Let's start by talking about app discovery. As you mentioned, our end users are using a wide range of cloud applications, not necessarily apps that are approved and officially onboarded by IT and security teams. With Cloud App Security, you can easily discover those applications, apply the relevant controls to the apps that you trust, and block apps that you don't trust. Using our integration with Microsoft Defender for endpoints, this process is super simple two-click deployment. We call that Endpoint CASB, and it really resonates with market trends that we're seeing towards enforcement, either at the endpoint or at the cloud service itself. Let me show you how this works in the product. So this is the Cloud App Security dashboard, and in the dashboard, we can see aggregated information about the different capabilities of the product. Things like open alerts, discovered applications, users to investigate, app connectors, and more. At this point, let's take a look at the Cloud Discovery dashboard and see the information that we get about the different applications in our environment. For example, I can see the amount of applications that were discovered in my environment, the amount of IP addresses, users, and the traffic load, both into the organization and outside of it. In order to get this information, I first need to enable the integration between Microsoft Defender for endpoints and Cloud App Security. To do that, I'll need to go to the Microsoft Defender Security Center settings and enable the integration using a single checkbox. The moment that I'll do that, data will start to flow directly from the endpoint to Cloud App Security to populate all that information that I just showed you. In the MCAS side, I'll just need to make sure that block unsanctioned applications is enabled in order to allow control on the applications and not just the population of the data itself. If we'll go to the Discovered Apps tab, we can see all the specific apps that were discovered in my organization and not just an aggregated view. For example, if I click on Microsoft Exchange Online, you can see that I can view a very detailed risk analysis on the app itself in categories such as security, compliance, and legal. And each and every one of those applications also get an overall risk score to determine the security of the app altogether. It's usually more interesting to look at lower scored applications. For example, let's take a look at risk score of 3 and below in the category of cloud storage apps. An interesting example here is FileDropper, a small cloud storage app that I can see that is being used in some users in my organization. When evaluating this application, it's clear that it's not an app that I would like to use in an enterprise environment, just because it doesn't support very important security standards like multi-factor authentication and user role support. And also, it doesn't support any of the common compliance and legal standards that I would expect from an enterprise application. In this case, what I would usually do is mark that app as unsanctioned, and I would want to block the usage of this application in my environment altogether. Using our integration that I just showed you with Microsoft Defender for Endpoints, the moment that I will mark this application as unsanctioned, it will be blocked on the endpoint as well. Let's see how it looks like from the user view. Now, I'm on a corporate machine in the same environment that I just unsanctioned FileDropper. I'll try to access FileDropper and see what happens. You can see that when I try to access it, the access is automatically blocked, and the end user is also notified due to a policy by the organization. The cool thing about it is that the only configuration that I had to do to make this work is those two checkboxes that I showed you earlier. I didn't have to manage any agents or do any complex configuration to make it work. It's so easy to configure and yet so efficient.
But what if I don't have Microsoft Defender for Endpoint? How would I accomplish the same great results?
Great question. We're also integrating with a wide range of secure web gateways, firewalls, and proxies through our log collector. So you can continuously upload traffic data directly from these appliances.
Okay, I got it. So what's next?
Let's talk about detection and UEBA. As organizations move critical workloads to the cloud, we're seeing that attackers adapt super fast and develop dedicated cloud-native attack vectors. And it's not just nation-state actors, but it's also financial actors and others that traditionally they weren't as sophisticated. Some of the recent techniques that we're seeing involve the use of malicious OAuth apps as a new phishing vector, use of malicious inbox rules to exfiltrate emails, ransomware on cloud services, and even the use of malicious images for crypto mining purposes. We have a top-notch security research team that are monitoring these attacker groups and their patterns based on the huge amount of telemetries that Microsoft has. We then apply all of this amazing knowledge into product capabilities to ensure that our customers benefit from our learnings as well. Cloud App Security can protect you against all the attack techniques that I mentioned using advanced machine learning and AI models that are battle-tested and now apply for anomaly detections, activity risk scoring, and UEBA. Let me show you how easy it is to enable detections and get started. In order to enable detections and UEBA, the first thing that we need to make sure is that we connect the apps that we want to protect using the app connectors. In this environment, you can see that there's already few apps that were connected, like Office 365, Azure, and AWS, and I can go ahead and add additional applications if I want to protect those. As soon as we connect those applications, user activities will start to flow to the MCAS activity log and will be enriched in the process and later can be used for investigation and hunting purposes. You could also create policies based on these activities to trigger alerts on a specific set of rules and filters that you'll define. In addition to that, all those activities also feed in to the out-of-the-box policies and detections that we have. Those detections apply sophisticated machine learning and AI capabilities to detect behaviors of users that is not only anomalous, but is also an indicator of compromise to help you detect suspicious attackers while minimizing the amount of alerts that you need to handle. Let's take a look at impossible travel, which is a super valuable detection to help us detect compromised users. For example, we can see here that we have a user named Risky Rick that was active from both the United States and Israel within roughly 200 minutes, at times it is not possible for travel between those locations. We'll give you all the context that you need for the investigation of this alert, including the mapping to the relevant MITRE tactics, so you could also understand the exposure that you have across the attack kill chain. You could then also go ahead and adjust the policy if you want to fine-tune it and scope it specifically for your organizational need. For example, to scope it to specific sets of users or set a different sensitivity level. And more importantly, you can also automate the investigation and remediation of these alerts, either through the built-in governance action that we provide or through a custom playbook that you can build within Power Automate that we integrate with. Lastly, you could also look at suspicious users from a different angle using our top users to investigate widget that will highlight the users that are most probable for you to look at. For each and every one of those users, we have a detailed user page with activity scoring for each and every one of the anomalous activities and alerts that we detected. For each and every one of those activities, you can see a detailed evidence that explained why we thought that this user is indeed suspicious. We constantly track new attack vectors and actor groups and then develop new detections for them to ensure that we have the best coverage possible.
Attackers are definitely getting better. It's interesting to see that they're even more active during these times.
Exactly. One of the biggest changes that remote work accelerated is the use of personal devices for work purposes. Suddenly, our users do not work on the corporate network with corporate machines, but rather use their own Wi-Fi network at home, along with their devices that are not managed by the organization. In this reality, enabling secure access to the sensitive information becomes even more challenging. With CloudApp Security, we can monitor the entire user session in real time and apply controls that ensure that secure collaboration. To do that, we extend conditional access to make adaptive access decisions based upon contextual factors. Things like the user, the device, the location, and many more. And extending that policy enforcement into the session allows us to strengthen the protection after the initial access has already been made. For example, we can configure a policy to block download from an unmanaged device. Let's see how this would look like. In this environment, I already pre-configured a session policy to block data exfiltration for a user named Sylvia. Let's take a look at the configuration of this policy. As you can see, I configured the policy to block activities as I want to prevent exfiltration, and then applied the relevant filters to ensure that I only block the specific subsets of activities that I'm concerned with. So for example, when we're talking about exfiltration, we're usually concerned about sharing items, downloading other items, printing, cut and copy items. All of those are relevant for exfiltration, and that's why I selected these. Then I applied the specific apps that I'm concerned with, mainly O365 applications. The specific users that I want this policy to apply to, in this case, just Sylvia, and then the device type that I want this user to use. So in this case, I only want the policy to take effect in unmanaged devices. So devices that are not Intune compliant or joined to Azure AD. With this policy configuration, anytime that the user Sylvia will try to do any exfiltration attempt on an unmanaged device, her attempt will be blocked. On the other side, she could still effectively collaborate and view all the relevant items. Let's take a look how this would look like to Sylvia as an end user perspective. As you can see here, I opened a Box instance. Box is a very popular cloud storage application. And I'll try to open a document that clearly includes sensitive information. In this case, you can see a list of social security numbers tied to people's names. You can see that this document clearly includes sensitive information, like social security numbers. As Sylvia, I can view this information, but I will not be able to do anything to exfiltrate or export this information. For example, if I'll try to copy some of the information, you can see that the action is automatically blocked within the session. Similarly, if I'll try to download the file to my computer, the same action will be blocked. It's super interesting to see that because these are exactly the scenarios that we're talking to when we say secure collaboration. Sylvia can still access the information, she can still collaborate effectively, but she will not be able to get a hold of the information outside of our organization. You could create similar policies with other controls to ensure secure access to your corporate resources.
But what about malware and ransomware? I'm hearing a lot of customers worried about those threats lately.
Yes, we discussed earlier that attackers adapt fast. And one of the unfortunate facts that we're seeing is that attackers leverage the COVID-19 situations for targeted attacks. Specifically, we're seeing the attackers develop dedicated phishing and malware campaigns against organizations highly affected by this situation, such as government, hospitals, and nonprofits. And to mitigate that, we developed few layers of malware protection in the product that complement each other. We use threat intelligence and sandboxing to detect malwares in connected cloud storage applications. Those are the apps connected using app connectors. We identify ransomware using machine learning algorithms. And lastly, we also introduced the capability to detect and block malware in real time as part of our session control capabilities. This is really exciting as it allows us to ensure that our environment stays malware-free without compromising productivity, which is exactly what we want to achieve with secure cloud adoption. Let's jump back to the demo to see some examples. Let's start by looking at the built-in malware detection policy. This policy will monitor the supported cloud storage application as soon as you'll connect these through the app connectors. As you can see here, in my environment, there were a few files that were detected as malware, some of them using our threat intelligence capabilities, and other using sandboxing. For each and every one of those files, we also surface the relevant metadata of the file to give you more context and understand whether this file really might be malicious. In addition, we also surface the malware family of that specific file and a dedicated report that our security researchers write about the malware families and the things that you should do to mitigate those. In addition to the built-in malware detection policy, we also have anomaly detection policies to identify ransomware activities. With these policies, we're looking to identify the behavior patterns of ransomware rather than just looking at signatures of suspicious files or specific extensions that we care about. This allows us to also detect unknown ransomware campaigns just by examining the user behavior and the behavior of the files themselves. As you can see here, we identified the manipulation of 74 files that had multiple extensions with the uncommon extension encrypt. It means that we were not familiar with that extension set, especially given the pattern of the file changes that we saw. Lastly, we could also configure a session policy to block the upload of potential malware in real time, just as I showed you earlier regarding the block of sensitive files to unmanaged devices. In this case, you could see that I configured the policy to control the file upload in this case, just for a specific set of users that I would like to monitor. And in this case, anytime that a file will be matched with malware, again, in real time, we will block the upload and also present a customized block message to the end user so they will know what happened and why they couldn't upload the file that they wanted. Let's take a look how this looks like from an end user perspective. From an end user perspective, you can see that I logged into OneDrive, and now I will try to upload the file suspected as malware. It's a test malware file that I prepared earlier. And this file should be blocked in real time keeping my environment malware free. Let's take a look. As you can see, the file was blocked, and there's also a notification to the end user telling them that it was blocked since it's a suspected malware that shouldn't be uploaded to the organizational cloud services. Malware is still a very important attack vector, and we will further expand our capabilities going forward. And with that, back to you, Joanna.
Thanks so much, Gal. That's all very practical advice and application for our customers. Hey, listen, everyone, we've appreciated your time and attentiveness today. If you have questions, please reach out to us directly on the Microsoft Cloud App Security Tech community. We appreciate your time and your participation.